Okay, so again, we're continuing with linear and exponential functions. Today's focus is more on that rate of change between those kinds of functions. So first of all, we talked about it a little bit yesterday, but when we talked about arithmetic, we can loop arithmetic and linear together because they both change at a constant rate, okay? They're both increasing by the same value or decreasing by the same value. So two different formats, but basically the same kind of behavior. On the left, you've got your regular slope-intercept form, okay, which is your y equals mx plus b or f of x equals mx plus b. And in that case, your initial value is your y-intercept. So when it's in slope-intercept form, your initial value is b. And the rate of change is your slope, so it's your m. When it's an arithmetic sequence, you get an equals a0 plus d times n. That is the adjusted from a1 plus d times n minus 1. So this is the same concept, okay? Except the a is 0. That's like your first, the initial term would be that. So your initial value here is your a0. And then your rate of change on the arithmetic sequence is d. But they almost behave in the exact same way. A line would increase with slope or decrease with its slope. An arithmetic sequence would increase with d or decrease with d, your constant. The only difference is what the graph looks like, which we're going to get to in a second. And then exponential and geometric can get looped together. Exponential functions are f of x equals a times b to the x. And geometric, without the minus 1 in the exponent, so again, this is adjusted. This would be an equals a1 times r to the n minus 1 typically. But if I want to compare these two, I want to make that I want to make the a1 become a0, so I'm going back a unit. And by doing that, I adjust my exponent to just be n. So these are very similar in their behavior. In both of these cases, and it doesn't say it here, but my initial value is a from the exponential function or a0 from the geometric sequence. And this time, your change is going to be multiplied. So your rate of change is going to be b or r. Now, what is like confusing in the questions is that they will give you this, and you could either get information in terms of the terms in your sequence, like it could say a2 equals 3, and it could say a4 equals 12, let's just say. Or it could give you in coordinate point form, and it would be 2, 3, and 4, 12. Those will act the same way. So if it's given to you in the format of that term, that a, God bless you, that a1, that a2, that a3, you can take it out of that and put it into coordinate point form, and vice versa. If it's given to you in coordinate point form, I can go back and say that that would be the same as a2 equals 3 or a4 equals 12. So you have to go back and forth between these two versions depending on what you're looking for. And again, the biggest difference is what the plotted graph looks like. If this is an exponential function and in a geometric sequence, this is what my sequence would look like, and this is what my exponential would look like. So the geometric is going to be individual terms, which gets individual dots, and the exponential is going to be a gradual line. Sure. If it was linear versus arithmetic and linear, my arithmetic is going to be dots that increase in a linear pattern or decrease, and my linear is going to be the actual line. So that's the difference between these two functions. Other than that, they behave exactly the same. They both have a rate of change, they both have the initial value, and they will both change in the same pattern. Okay, the domain of sequences is going to be a list of discrete points. So if I was to list the domain of this, it would be like 1, 2, 3, 4, like that, and so on, okay? And if obviously I'm giving the domain of my exponential or my linear function, then it's one interval from negative infinity to positive infinity. So that's also a difference. All right, change in output values. So over equal length input intervals, if the output of the values change at a constant rate, meaning second minus first, third minus second, fourth minus third, like that, is constant, then it's linear, okay, which also means arithmetic. If the change is proportional, meaning the second over the first and the third over the second and the fourth over the third are the same, then it's exponential or geometric. So you'll get given like a chart, or you're going to get given values, and it will say, is the given data, is it linear or is it exponential? Is it arithmetic or is it geometric? And they would look like this. A function has the following coordinate points. Could the function represent a linear, exponential function, or neither? So when I look at A, the first thing you want to do is compare your x values. Are they increasing or decreasing in the same interval? Yes, these are all going up by ones. So then if I want to figure out if it's linear or exponential, linear, I'm going to do 4 minus 1, 16 minus 4, and see if they're the same. Are those going to be the same? No. So then exponential, I do 4 over 1 and 16 over 4. And are these the same? Yes. So this is exponential. Now I go to B. Are my x values or input values increasing or decreasing on the same interval? Yes, they're going up by 1. So now compare your y values. From 3 to 7 and 7 to 10, 7 minus 3 and 10 minus 7, are those the same? No. 7 over 3 and 10 over 7, are those the same? No. So this is neither.
Why is the first one exponentially?
Because the second term divided by the first is the same as the third term divided by the second. They both be 4, right? 4 over 1 and 16 over 4 both be 4. Okay, now I go to C, and it says 3 to 5 and 5 to 7. Is that on the same interval? Yes. So I'm not going by ones, but it is still the same interval, right? So I would do 7 minus a negative 1 and 15 minus 7. And for these I get 8 and 8. So then this is linear. If I did 7 over negative 1 and 15 over 7, those are not the same, which would rule out your exponential.
So you look at the y?
You have to make sure the x is going up in equal increments or going down in equal increments, and then you look at the y.
Okay.
Yep, first thing you have to check is the increment, then you do the y's. So this is, linear is still first difference, like if you compare it to what we have already done with our data, it's still the first difference. Exponential is proportional, so we're adding that to one of the things that your function could be. Okay, example 2. A says f of x is a linear function and it passes through 3, negative 1, and 7, 15. Write the equation for this function. This is an Algebra 1 skill, just put with extra words. That's all it is. It's basically giving you 2 points and asking you to find the equation of your line. How do you do that? It's 15 minus a negative 1, and it's 7 minus 3. So it's 16 over 4, which is 4. That's your m. Okay. Then you can plug it into point slope or slope intercept. So y minus y1 equals m times x minus x1. Or you could do y equals mx plus b. I don't care which way you do it. And pick either point. Because you make silly mistakes with negatives, I would maybe just go with the 715 in case. But really, it doesn't matter. So y minus 15 equals 4 times x minus 7. Y minus 15 equals 4x minus 28. And then add the 15. So the only difference is, what is it asking for? What does it say at the beginning? f of x, right? F of x is a linear function, which means the only thing I got to do is change that y to f of x because we know it's a function. Questions on that one? Yeah. Yes. Yeah. Okay, B says f of x is an exponential function. Now it's exponential. That passes through 2, 1, and 4, 16. Write the equation for this function. There's a couple different ways to do this. But in my opinion, because we're fresh off of geometric, let's do it that way. So 1, we get to review that, but 2, we talked about it yesterday. If it's exponential, we can take these points and turn them into geometric sequence values. So 2, 1 is the same thing as saying A2 equals 1. And 4, 16 is the same thing as saying A4 equals 16. Now we have geometric terms, right? And yesterday we did AN equals A1 times R to the N minus 1. And we said we can manipulate that for any terms we have. So if I don't have A1, which I don't, I have an A2 and I have an A4, I can take those values and I would make the left one my A4. I would make the right one my A2, and then what's going to be the X one on R? 2. So now plug in your A4, which is 16. Plug in your A2, which is 1, R squared. And I get R is equal to the square root of 16, technically plus or minus, but we don't do plus or minus when you're finding out the rate of change. It's just square root, which would be 4.
Do you have to find A1 now?
So it says write an equation for this function, right? It doesn't specifically say that your A1 has to be your initial value, which means you actually have options here. You can say, using my A2, wait for it, I could say AN equals A2 times R raised to the power and adjust that. So instead of being N minus 1, it'd be N minus 2. Or I could use A4. And I could say AN equals A4 times R to the N minus 4. You can use either one. Hang on. Okay, so we can use either one unless it explicitly says you want your initial value to be 1 or you want your initial value to be 2, whatever that is. I basically have two options. I can use my A2 as my initial value, so I can say AN equals A2 times R to the N minus 2, and then I can plug in those values. So I would say AN equals 1 times 4 to the N minus 2, and I would just go a step further and make that 4 N minus 2. That's one thing you could do. You could also use your A4, so AN would equal A4 times R to the N minus 4. And I would get AN equals 16 times 4 to the N minus 4. So if it's an open-ended question, both of those would be accepted. You could even work your way backwards to get an A1 and use that. If it was multiple choice, you would see obviously one of those, okay? And a lot of times it will say which of the following could be, which is how the wording would be, could be an equation to represent this function, and it would be in that format. And then at the end, actually, the last thing we're going to do is rewrite that so it's a function. F of x equals 4. And n minus 2 can also be rewritten as x minus 2. So this becomes your input. Or f of x equals 16 times 4 to the x minus 4. So these are usually multiple choice. You'll only see one of those options listed, okay? Not open-ended because there'll be more than one option. But if it was open-ended, then either of those would be right. Questions so far? Okay, example 3. Says find the following functions are either linear or exponential. Identify the constant, slope, or ratio that causes the output values to change. So first thing is it linear or is it exponential? Second thing is what's your rate of change? So in A, is it linear or exponential? It's linear. And what would be my rate of change? -2. Easy as that. If it asks for your initial value, it would be 3. Good. All right, then B, is that linear or exponential? Exponential. 10, what's the ratio? 3 is your initial value. That's your A1, right? That's your initial value. So what's your R? 5. Questions on that one? All right, example 4 says determine whether the functions are linear or exponential and justify your answers. So instead of giving it to you in coordinate point form, it's giving it to you in chart. Same exact thing though. Look at your x values, your input values. Are they changing in the same interval? 3 to 7 and 7 to 11. Is that the same interval? Yeah, they're both increasing by 4, right? So now look at your y values. Is the difference the same? 6 minus 10 and 2 minus 6? Yeah, they're both negative 4. So this is linear. Go to B. Are we increasing our x values by the same? Yes. Now look at your y values or your output values. 6 minus 2 and 18 minus 6. Are those same? No. 6 over 2 and 18 over 6. Are those the same? Yes. So this is exponential. Questions on that one? All right, and then this is what like an AP style question kind of looks like. It'll say for an arithmetic sequence S of n, so it changed your variable, okay? S of 2 equals 10 and S of 5 equals 22. What's the value of S of 12 minus S of 9? There's a bunch of different ways to do this, but first thing you got to notice is it says arithmetic. It has to tell you what kind of sequence it is. It will either say arithmetic or geometric, okay? If it's arithmetic, God bless you, this is like a line. So it basically just gave you 2 points, 2, 10, and 5, 22. Whether it was arithmetic or geometric, I can put it into coordinate point form, but if it's arithmetic, I put it into the coordinate point form and use my y1 to find the equation. If it's exponential, I would put it into my geometric form, which is it would be A2 equals 10 and S5 equals 22, and I'd plug it into the exponential function. So that, or the geometric function, okay? Figure out which one it is, and then based on that, you'll know what to do. So because it's arithmetic, we treat it like it's a line. First thing I'm going to do is find my slope or my rate of change. 22 minus 10 over 5 minus 2, and I get 12 over 3, which is 4. That's your M, or your rate of change. Then I'm going to pick either point, doesn't matter which one. I'm going to grab the first one, and I'm going to make the equation of the line. So y minus 10 equals 4 times x minus 2. Y minus 10 equals 4x minus 8. And y equals 4x plus 2. Now, I'm not giving that as an answer, so I don't care about changing it to f of x. I can keep a y. I'm just going to now use that to find s of 12 and s of 9. So s of 12 would be y equals 4 times 12 plus 2. And s of 9 would be y equals 4 times 9 plus 2. 48 plus 2, which is 50. 36 plus 2, which is 38. And it says, what's the difference between them? So 50 minus 38 is 12. You can also think of it as how many jumps do I have to go from S9 to S12? I'd have to go from 9 to 10, 10 to 11, and 11 to 12. That's 3 jumps. That is 3 rates of change. So it's 4 plus 4 plus 4, which is 12. So how you do that is up to you. You have to find the rate of change either way. And that is the behavior I would follow if it was linear or arithmetic. If it's geometric, because you're going to see that too. If it was geometric, I would take my S2 equals 10 and make it A2 equals 10. And I would take my S5 equals 22 and I would do A5 equals 22. And I would do A5 equals A2 times R to the third to find your R. So if it's arithmetic, it's a line. I treat it as though it's a line. If it's geometric, it's exponential, and I treat it as though I keep it in the geometric form that we did yesterday, okay? So biggest piece of information they give you is what kind of sequence it is to begin with, and then that tells you what to do after it. Questions? Okay.